Welcome to this week's Purdue at Westgate's Defense in Indiana webinar series. My name is Morgan Tavis, and I am the Marketing and Communications Manager for the Purdue Foundry Westgate at the Westgate Academy. We at Purdue at Westgate strive to promote business and talent growth, and we want to help support you as a startup, small business, and academia. We strive to be the regional hub of connection and support. Purdue at Westgate is located within the Westgate Academy. The Westgate Academy is a technology incubator / training and coffee conference center that is located within the Westgate Crane Technology Park, which is located directly outside the gates of the Naval Support Activity Center in Crane, Indiana. We would like to thank our sponsor and presenter for this webinar, CACI International. CACI International Incorporated is an American multinational professional and services and information technology company headquartered in Arlington, Virginia. They provide services to many branches of the U.S. federal government, including defense, homeland security, intelligence, and healthcare. We are excited to have a satellite office of CACI within the Westgate Crane Technology Park supporting NSWC Crane. Today, we are excited to be hosting a webinar with Tim Anderson. Tim is the Model-Driven Design and Implementation Analyst at CACI. He will be presenting on how CACI's system engineering approach embraces model-based systems engineering to streamline executives of systems engineering lifecycle phases. We ask that you mute your microphones, and if you are comfortable, you may turn your videos on during the presentation. Please feel free to use the chat function at the bottom of your screen to ask questions, and Tim will answer these at the end of the presentation. Following the webinar, a copy of the presentation and the recording of the webinar will be sent to you via email. I will now send it over to Tim.
Thank you, Morgan. Can I get a clarification? You guys can hear me and see my screen?
Yes, we can.
Perfect. Thank you very much. So as Morgan mentioned, going to be demonstrating and presenting on model-based systems engineering and CACI's approach and process for implementing that discipline. So our implementation is called Model-Driven Design and Implementation, or MDDI. And we'll walk through those in the next few slides here. Just a little intro about myself. I've been doing MBSE for about 10 years now, working in the industry, training and consulting on the different frameworks and languages within MBSE for the last 6 years or so. DoDAF, SysML, UML, if you're familiar with those concepts, they really are the hallmark of what we do with MBSE. I joined CACI about 3 years ago. I've been working with the core MDDI team here with several Navy and Army contracts and projects, delivering lots of different good features and acceleration to provide the value that each of those projects are needing for the individual contracts. With that out of the way, let's get into the actual presentation. So MBSE really is a paradigm shift from document-based engineering. We're focusing now really on a model-centric approach. Done are the days with the disparate sets of information. We're no longer keeping track of content in Word, Excel, PowerPoint. Now we want to focus on a model-centric approach with a single integrated repository so that we have a single truth of data within a centralized location. MDDI takes this concept and we help integrate all these different concerns about your design and your architecture within this repository. That includes your objectives, requirements, design, any testing and implementation. All of that is collected and analyzed and realized within this process. It's a capability-driven approach. It helps us trace those capabilities and requirements from a very high level, maybe business processes, throughout your architecture to lower level system functions, interfaces, and even subsequently down to your data fields. It helps promote interoperability between systems. Having a central location and definition for your systems and your models allows for reuse across other projects and other contracts. So at an enterprise level, we're able really to see those different system designs, and they're able to actually interoperate between each other in higher level views where we can show individual systems interacting with each other. And at an enterprise scale, we can actually see these different pieces of the environment working together to produce several new capabilities that on their own they wouldn't necessarily be doing. This process supports testing, which you'll see later on. We help build into the design itself the test cases. It allows us to capture not just the system design and validate that design is conforming to a proven framework or language. We really get verification that the design itself is meeting the requirements with that traceability throughout the architecture. So we're constantly able to see an entire spread of information from one point to another within this repository. Using something like simulation is very key. Again, with it being in one location, we have the benefit of simulating these systems to see their behavior, maybe moving from one state to another or walking through a process. Simulation gives us the ability to really verify that the system is performing in the manner that we expect it to, given alternative paths or different stimuli within its environment. We want the system to perform and interact in a designed manner. And so we use simulation to do behavioral analysis like that. Later on, we'll also talk about trade-off analysis using this same approach and performance metrics to make sure that we are hitting, say, a desired performance value like speed or timing. All of that is nice and intricately woven into this approach. And as I mentioned, with all of these different moving parts, it really does help us to enable these system-to-systems complexities where we get to see these systems. We can dive into a lower level system and see its inner workings and really see how these things play together in one cohesive environment. So that's really the benefit of MDDI and subsequently its MBSE foundation. There are many benefits to MBSE in general, but more specifically for our approach, MDDI. As I mentioned, the hallmark really of MBSE is that integrated architecture, having a single source for all of your different concerns within your architecture and your design is pivotal because we're able to take those individual pieces and trace them to other objects within the architecture or the repository. We're able to do version controlling, so we can keep track of the change of that element over time. And we're able to do analytics based on the connection points and the different metrics that are captured within that individual model. Things that you wouldn't get to do with a document-based approach. Tracking a change of even something as innocuous as a system name throughout a document-based approach would really require going through each individual piece of material and making those individual changes. With an approach like ours, we have a single location. We can make the change in one spot and it'll be replicated across the entire architecture. So changes are incredibly simple to make, and it's easier to track things like the impact that that change might have on the overall architecture itself. Impact analysis is a very big benefit that we get from having this integrated repository. We're able to query the model to say, for that one example, that one element, if we make a change to this element, what all things are it connected to? We see very easily all of those traces throughout the architecture. If I want to make a change to something as low level as, say, the type on a data field, I can see that thread, as I mentioned before, all the way through the architecture to see which requirement or which capability might be affected by something as simple as changing the size of a data field. Those things are not simple to capture in a traditional approach, but MDDI and MBSE allows us to follow that thread and manage those connections much easier. Also helps us with interface management in the same vein. We're able to track each of those systems and their interdependencies. Any interactions from one system to another are captured within the repository. We see the common points of connection, and with ports, some network, all of those things are tracked and captured. Common exchanges between systems are tracked and managed. We're able to see that information being passed between one system and another. And we can see the properties. We can decompose those exchanges into those lower level fields to see what exactly are these messages made of, what kinds of information, what is the exact information that's being sent from one system to the next, so that we could do something like transformation of data or logic that describes how we take some interaction from one source system and deliver it to a target system. Any metrics associated with those exchanges, availability, timeliness, throughput, those are all captured on those interfaces. So we're able to see the level of complexity for different interfaces, the amount of work that would be needed to develop those interfaces is all tracked and managed, and it helps to inform us when we're going to do the actual development of our actual built design. Those concepts are pivotal in informing us when we should start developing certain pieces. Depending on those complexities, we have a more informed decision on what needs to precede others and what we need to do to make sure that we have a successful development phase. As we'll point out later, we want to make sure that the design is always in sync with the development, that the design is always informing the development, and vice versa. We want to make sure that any updates in development come back and are replicated and shown off in the design itself. One of the advantages of doing a model-based approach is that since we have these digital models that, again, can be reused throughout the enterprise, we get the benefit of being able to capture standards, open standards, and be able to show that we are in compliance to those individual standards. The DoD has several standards that they expect different contracts and proposals to support. And it's incredibly simple and straightforward to show that we're meeting those standards and that we're aligning to those standards by just using those catalogs of those standards within a model-based approach. We have captured several different standards. We'll explicitly go into the NIST security standards later on in the presentation, but other standards like data standards we capture as well, and we align our fields to those standards to show that not only is our information good, it's consistent with what the industry or the governmental standards are. So we can show alignment, and it helps promote interoperability between these individual views. So MDDI itself has a collection of defined profiles and catalogs of these individual standards within the industry and government. And it really is incredibly beneficial to be able to link those things together within the repository itself. All right, MDDI specifically is built on really three pillars here, and you see in this Venn diagram. We use models, open visual models that allow us to capture a digital representation of the design using MBSE really as a backbone. And it allows us to trace, again, to those standards, and it allows us to implement that design very easily. The method itself, sorry about that. The method itself is, let me see if I can pause this. There we go. The method itself is, as you see here, disciplined, repeatable, and optimized. We've been using the same exact practice, the same method at its foundation for over 10 years now. And as we continue to go project to project, we learn more, and we always bring that into the method. So the method itself is constantly getting better, constantly improving, and adapting to the industry's needs as we approach each individual contract with fresh eyes. That method is brought in and is used and best used really through all of the automation that we've helped to develop to expedite a lot of this process, this MBSE process. When, traditionally, again, document-based engineering, you'd have to write down all of these different procedurals, your SDDs, your IRSs, your ICDs. All of these documents are manually captured, manually traced. Most of that content, though, can be algorithmically calculated based on an already existing digital design. And that's really one of the huge benefits of MBSE and MDDI is we are able to model our design digitally, and then we can generate all of those procedurals to be delivered to the stakeholders. Because stakeholders, in general, still want to see these formatted and defined procedurals, but you don't want to manage those constantly while you're trying to do your design. It's very tedious and very difficult to keep in sync while you're building your design. So automation really is pivotal in making sure that your procedurals are not only consistent across one another, there'll never be misspellings, there'll never be inconsistencies in data across the procedurals because they're generated from a single source within the repository. All of those linkages, all of those traces really do help to ensure that we are capturing the most current design as it is in the repository, and that it's being populated into those procedurals. And with a single click of a button, you can generate all of your individual stakeholder documents and hand those off. And as the design improves, you just generate them again and replace them with the new copies. It really does save a lot of hassle, a lot of headache. In addition to the document generation, though, we also have automation for capturing data and using that data within the repository. We have a lot of information that needs to be collected and captured and brought in to the model. And so we have automation to help do that as well. A lot of standardized templates for ingest of data, as well as the output of data. MDDI itself, as you can see on the left there, is an MBSE methodology for capturing, binning, and using the data. And we really do support all of the different types of development methodologies that I'm sure most of you have heard about, like Agile, waterfall, spiral. All of these different methodologies can be used directly in concert with MDDI. And it's highly tailorable to fit whatever actual development methodology you intend to use on your individual projects. Some of the key distinctions of MDDI really are it's a system of systems approach. We focus not just on an individual view of a system, like a structural view or a behavioral view. We really want to show how individual conglomerates of systems interact with each other and show them working in concert within an enterprise. We have interoperabilities between many different tools within the MBSE space. You'll see here listed DOORS, HPALM. Those are requirements management tools. We integrate with those to capture requirements and keep in sync with changing schedules. We also integrate with other Agile development tools like Jira or version 1, integrate with solvers like MATLAB and Modelica, lots of interoperability, specifically through MDDI, so that you don't have, each tool itself has its own specialty. The MDDI enterprise architecture repository doesn't need to do it all. We can interact with those individual technologies to let them offset some of the powerful analytics that they provide. As I mentioned, we generate procedurals with MDDI's accelerators. These are just some of the notable examples: IDDs, ICDs, VDDs, SRSs, STDs. The templating mechanism itself is highly flexible. For most of the contracts that we support, we produce customized templates, so you're not just getting procedurals, canned, DoD procedurals that are necessary for stakeholders. We also provide the flexibility of fit-for-purpose views as well. It is incredibly flexible and easy to use, and we get the advantage of being able to produce documentation that's not just used to be stored on a shelf. It actually is going to be used, is intended to be used by the developers, by the team, so that they can take the good information that we've built within the repository and go build that design that we've built. It is DoDAF compliant. MBSE in general doesn't really conform to any one particular framework or language. DoDAF, though, is a very proven framework. It's been around for a very long time, and it helps to capture and bin all of the different concerns for each of these MBSE efforts, giving you a spot specifically for your capabilities, for your system concerns, your mission objectives, your requirements, and your services even. These things are all binned in their individual respective locations. And within those viewpoints, you have lower level views that help give lower level concerns for each of that binned information. It's a very useful framework that we leverage heavily. And you'll see here in a few slides that we have customized as well to add additional content to the framework where it was lacking. And so this is the approach for MDDI. This is a nice overall view of what MDDI is. So as I mentioned before, one of the key issues with trying to build out a design is moving away from a document-based approach and moving to a model-based approach. Now, again, document-based engineering has been around for decades now. And for most of the ventures that you'll see within MBSE, you're moving from an older version of a system, and we're trying to upgrade it to modern technology, either through some transformation process or some tool modernization. These are the things that you have existing information in disparate sources, whether that be Excel spreadsheets of requirements, spreadsheets for interfaces. Some of the information can be captured in PowerPoint, like schedules. We could have little Visio diagrams, boxes and arrows that help try to do a first approach at model-based engineering. Word documents, PDFs, all of these things are kept completely disparate in different views. And what you really need to do is we need to collect all that good information, well, sometimes good information, and we need to ingest it into a common repository so that we can really analyze that content and start immediately getting those benefits of MBSE out of that individual pieces of information. Couple downsides, couple things that you got to look out for. It's not really a downside of MBSE, but a downside of the document-based approach is that you'll get inconsistencies within the different views, the different bits of information that you're given won't necessarily always coincide with each other. And that's really a issue with the document-based approach. You don't get the single source of truth view that a model-based approach gives you. So you really do have to not only ingest the data, but rationalize the data. And once you get a chance to see it in one location, you're actually able to see the true design and the true implementation of an individual system within that repository. And you have truth then within the repository to move forward. MDDI has several accelerators, as I mentioned before, for ingesting of that data. We've ingested, as you see on the list here, all of those different types of information. There have been ingested through MDDI for use in our different projects. Each project comes with its own set of information, which could use, customized spreadsheets for that need to be brought into the model. And our flexible accelerators that we have allow us to grab that information in whatever format it may be in. But once we get that information out of those spreadsheets, out of those Word docs, we bin them into a defined framework. As I mentioned before, DoDAF is our go-to framework, where we take all that information and we really do properly put them into a cohesive and coherent framework that allows us to really get a chance to see the different concerns of the design itself, of that individual system. So we're able to visualize the aspects of the design and really understand what the system is doing and get a chance to then start seeing all of our rationalized output. And that's what you see over here on the right-hand side. With it being a single repository, you get so many things just out of the box that you would not get within a list of documents. With the information, we're able to do informed trade-off analysis. So if we have multiple systems performing a certain functionality, we can very easily see all of the different implementations for that functionality, and we can verify which one best meets our needs, maybe doing an analysis of alternatives approach where we see cost or other factors factored in to give us that informed decision on which system should be used. Moving forward, this is good for COTS selection, commercial off-the-shelf selection of products and parts. We can very easily see which one best suits the needs of our individual design. With it being a repository, it is a standards-based modular architecture. We intentionally make sure that all of our things are going to be easily accessible and easily integratable into other larger enterprises. Profiles, catalogs, and other implementations are heavily relied upon within MDDI. We build out all of these reusable modular pieces and profiles, and we reuse them over and over again throughout all of our different contracts and projects. Because it's been built once, we can reuse them, and since they're standards, we are able to see and do analytics on the individual connections that we have throughout our enterprise and all of the different projects that we support. As I mentioned, generating the seed rules. This is really taking the information from those different disparate sources, rationalizing them, cleaning it up. As I mentioned, there's a lot of issues with bringing in these individual pieces. And once we've cleaned up that data, we then just hit a button and generate all of those artifacts back out, but now completely cleaned. And now they are completely consistent with one another. So all of those documents that we had before can be immediately regenerated, and without any effort whatsoever, you can instantly see wherever we've done those rationalizations and captured any inconsistencies. We can give you a fresh, clean slate of documents that properly define the system. Again, that's just out of the box the minute we bring the data in, but as we continue to refine the design, as we continue to update and build our new architecture, our model, those seed roles are just going to continuously be generated whenever they're needed to be given to the different stakeholders and development teams. One of the things I've mentioned, but haven't gone into too much detail, are the analytics of the data. With it being in one location, we're able to follow a single trace from one element to the next. We're able to do roll-up counts. We're able to do value simulation. Those individual concerns that would be in different bits of data sources, now we can realize all of the different metrics associated with the pieces of the system, and we're able to produce analytic tables and metrics tables that help to show the different values or measurements of the system itself. We've done this specifically for interfaces, where we've collected several different sets of metrics associated with interfaces to rationalize. One of the more recent ones that we did was about 6,000 or 7,000 interfaces that we were able to rationalize into a dashboard of 100 or so individual interfaces to show complexity amongst those 100 individual systems. And again, the benefit here is you get a full view of what is going on within the design, and then you make informed decisions based on those individual concerns. So that's really MDDI and MBSE in a nutshell. Now moving forward, we'll move on to the individual things that MDDI brings to the table on top of that. One thing that we have is a roadmap. This is a standard product of DoDAF called an SVA. It's a roadmap of the system deployment. It captures shutdown and launch dates of individual systems. What we do with MDDI is we integrate this into the master project schedule so that we inform, specifically for Agile, the Agile sprints or release schedules of other methodologies, where give us the ability to inform those dates in those schedules so we know when these systems are coming online, or if it's for a modernization approach when we're taking other existing legacy systems offline. And this may seem pretty simple, just tracking the roadmap and the dates themselves, but this is also integrated with the capability phasing view, which you'll see here. We want to track when the capabilities of the architecture are being exhibited. And that's really key, because if we have a point in time where we drop a capability, we will not in the real world have that be able to perform that individual capability if the system is dropped, say too late. Maybe we shut down a legacy system, but the system that's meant to replace it doesn't come on for another week after the shutdown date. You have a week's worth of a gap where that capability just won't be realized, which has real world implications. And you can track that to a degree with the project schedule, but having it integrated into the architecture, we can do these what if scenarios. Say multiple systems are performing a similar function, you can play around with this roadmap and figure out if we turn on the functionality in one system and turn it off in another, we can get by with these schedule slips and really understand the impact of shifting a schedule left or right. A tactical use for MDDI. Here you see a use case diagram. This is a user-centric view that allows us to see a piece of user functionality. This is from one of our Navy contracts. The key thing here is we're using these use case elements to help make a digital thread throughout the architecture. You see at the top left, that green object is a capability of the architecture, which traces to a business process and operational activity in blue, which is implemented by a function, which is the orange on the right-hand side. That function details the steps and the participants involved within that process. And it really allows us to show the different concerns of the system and how the system is actually going to implement that business process. We also have data views here, right below that maintain initial gain summary function. These are the data fields that are being passed within that process. So from system to system or system to user, we can see the data associated with it. And this really is a very nice view to show the integration of all of these individual concerns within the architecture and how they all really trace together. There are underlying traces behind the scenes connecting all of these individual elements together, but this is a nice visual that shows a single thread through the architecture from a capability down to a user story or a data field. As I mentioned before, most of the contracts nowadays that we've been working with are Agile. It is a very popular methodology for development. And with MBSE specifically, it's incredibly simple to keep up with that design using the MDDI approach. The MDDI approach is tailored and flexible to allow us to keep up with a sprint-based schedule in Agile. As you see here in the middle ring, Agile is built on a principle of sprints where you have a detailed design phase, you create some artifact, you test that artifact, and then you show a live demo, and then it's rinse and repeat every 2 to 3 weeks, depending on your sprint cycle. It's a user story approach where you take individual user stories and you implement them. We make sure that those user stories in the design are captured, and then we let the development team take the good work of the design, run off, build it, and come back. Now, things like choosing those user stories for each of those sprints, scheduling the different sprints, all of that information needs to be well informed, and you can't just run off and just write down these individual concerns just willy-nilly. You really need to have some logical and informed decision-making behind the scenes to drive why we're doing what we're doing and when we should do something, depending on complexities or any number of other factors. So MDDI has a direct Agile integration with development tools, like I said, like Jira or version 1, where we help to populate the backlog of those development tools with user stories that were built and defined directly from the design. Now, this is tailorable. This is not a hard, fast, design first, model second, or design first, develop second approach. We work with the development team. We really want to be in sync with the development team, and we want to be a help to the team, not just an overarching burden. So we work directly with the development team. If they have user stories that they've defined, we ingest them into our model and capture them in the design and make sure that they're accounted for, and that the impact of adding that user story and that functionality doesn't change the necessity of the schedule for the individual system design. So we work either direction or in concert with both. But the big thing here is we want to stay in sync with those developers. Whether it's us populating user stories directly into the development tool, or it's the development team coming back to us with user stories. Now, regardless of the direction and the approach, we want to make sure that both sides are informed and both are providing active feedback to each other. So we as the designers will help inform the developers what it is they're trying to build, give them a larger picture than just a singular focused user story. And the developers can come back to us with feedback where maybe the implementation of one of these user stories required changes to either requirements that were unaccounted for or metrics that weren't captured properly in the design, where we actively need to make those changes and see those the reflection of that concept in the design itself. So it is back and forth until we're able to produce an MVP, those minimum viable products, where we can do a live demo and show that we have achieved a proper end to one of our sprints. As we're doing our architecture work, we always want to be keeping up with the security concerns. Cybersecurity is a huge thing, especially nowadays in the DoD and in industry. And we want to make sure that we are always keeping track with all of those concerns, and that we can show that we have not only accounted for the concerns, but we've mitigated everything that we have been able to. RMF is the risk management framework, and we support all of the different steps associated with the risk management framework. There are 7 of them, but we help expedite the first 3 specifically. Steps 0, 1, and 2. On the little circle on the left-hand side, there's 0s in the center. That's our prepare step. Prepare helps to establish an initial risk assessment, helps to monitor strategies, and do asset identification, as well as many more tasks. It really is capturing the design early on. Then we need to categorize the information systems. So we use the NIST standards to help bin the information in systems. That way we can do an accurate risk assessment. And then step 2 of selecting the security controls. We have the NIST standards captured within our profiles. And we give the ability through acceleration to very easily walk through those security controls and really link them up to the architecture in a simple, straightforward manner, but to make sure that we've captured all of those concerns that we need. With this pyramid, as you see here, we've built our cybersecurity implementation on proven foundations of frameworks. At the very bottom there, you'll see the UML language, the Unified Modeling Language. It's really the root of most of these MBSE languages and frameworks. It helps define the language that will be used throughout MBSE. The DoDef framework on top of that is built. Again, we leverage that highly. UPDM Security Viewpoint right above that is part of our MDDI customization to UPDM. I mentioned that we have several customizations to the framework, and this is one of the key pieces that we have brought to the table. So it helps to capture the different security concerns specifically for cyber here. Using that security viewpoint, we've captured the NIST security controls within the viewpoint itself. We keep those up to date as those are updated and put out by the DoD. Using those security controls, we have the risk management framework as a business process within our profile. So you're following the RMF process step by step using the defined standards within a captured catalog. And then finally, we want to focus on the security concerns. This is where you really do your specific project-specific needs. And we, again, weave those concerns throughout the architecture using this proven foundation. So it really does simplify the ability to capture these concerns, which, again, is a very hot topic nowadays. Also, we talked about doing Agile implementation a few slides ago. We talked about the feedback loop between the Agile team and our design team. And one of the things that you really need to account for is or are changes made to the design or to requirements. It doesn't matter what project you're working or what contract you're on, inevitably there will be changes. Not everything will ever be accounted for, and no stakeholder will keep their mindset on a solid single path. So what you have are changes that are given to you within your design that you need to account for. And sure, you could go in and just change a name or add an interface. But if you do so without any informed decision making, you could be interrupting either capabilities or messing up a design constraint from some other requirement that you had within the architecture. It's not very simple to just be told you need to cut your runtime in half and then to go into the model and just say, yes, it operates at half the time. You really do need to account for that change and see what is it that's causing my runtime to take as long as it is, and what can I do to minimize that time and try to meet this new goal. MDDI has an impact analysis feature where we're able to make a what if change within the model to say a requirement, and then it will flag everything in the model that was connected to that requirement. So we can very easily see if a requirement such as this changes, what are all the different pieces of the architecture that are, even at just a first level, affected by that change. That change list, that output is reported out and tracked for a change management process where we can walk through the model and verify for each of those individual connections that each of those design concerns have either been addressed or the mitigation has already been taken care of. Sometimes, a requirement change doesn't require an update to the model, but more often than not, you need to verify what all it will be impacted, and more often than not, you will have to make some kind of a change. So really, the impact analysis gives us the ability to ensure that we are meeting design compliance with whatever updates have been made to those requirements. And then to close out, what you see here are just a list of the different values that we've provided for some of our previous clients, like specifically the GPNTS project. That's the GPS-based positioning, navigation, and timing service for the Navy. This particular slide was built out for that, that venture, but we've added other content as well. So best practices, model reuse, domain-specific training. We did fit gap analysis, again, modeling the security concerns, doing requirements management, tech-based system wiring variability for that fleet. We also provided a CPD document, capability production document, and other dynamic fielding plans, again, based on the roadmap that you saw before. So again, MDDI really is a very honed MBSE approach that doesn't just capture design. We're not just focusing on building the design for a system. It really is soup to nuts, walking from capturing and preparing the data all the way through to the implementation. We really want to be hand in hand with the developers and the testers as we move forward to ensure that the design is as accurate as it can be and as optimized and best built as it possibly can be. And that is it for my presentation. We have, I think, about 10 minutes now. Let me check to see what questions we have.
Doesn't look like we have any questions in the chat box, but if anyone else wants to raise their hand or put something in the chat box or unmute themselves, feel free. All right. Well, Tim, did you have anything else, or are you done?
That is it for me. Thank you, everyone, for your time. I really do appreciate this. And I hope you have a great afternoon.
Perfect. So Purdue at Westgate would like to thank Tim for joining us today and for sharing us his expertise on model-based systems engineering. I'm sure Tim would be more than happy for you to contact him with any further questions you might have. As mentioned before, a copy of this presentation and recording of this webinar will be provided to you via email. Again, a very big thank you to CACI for sponsoring and providing the presentation for this webinar. Make sure you check out our website, www.westgate-academy.com, and click on the tab Purdue at Westgate webinar series to find a Defense in Indiana webinar series to learn more about our future events. We hope you enjoyed this, and we look forward to potentially meeting you all in the future. Have a great and safe rest of the week. Thanks, guys.